Hello and welcome back to Maths with Mr. Duffield. I think this is going to be my last video of the day. It's just bringing my GE awareness to this work I've set on bearings. This particular question. It's on exercise 2 on the map scales and constructing bearings section. Question 4. It reads, a ship is at a bearing of 70 degrees from a ship. It's not that word ship there shouldn't be ship. It should be a lighthouse. And I profusely apologize because obviously a number of you have been confused by that. And it's really put you off actually the next few questions, even though questions 5 and 6 are actually absolutely fine in their wording. That one has really tripped up some people. I'm going to work through that question, having made that correction, and hopefully you'll be able to have a go at the subsequent questions as well. A ship is at a bearing of 70 degrees from a lighthouse 6 kilometers away. Clap Island is at a bearing of 150 degrees from the ship 4 kilometers away. By first plotting the locations of the ship and the island, using a scale of 1 centimeters equals 1 kilometer. Estimate how far away the island is from the lighthouse. So it's a measuring task, and I'm going to be able to measure this once I've done the constructions of these bearings. Okay, so there's a ship and it's 6 kilometers away from a lighthouse at a bearing of 70 degrees. So actually from the lighthouse indicates that actually the lighthouse is where I'm going to start from. So here's a dot that represents my lighthouse. There is a north line that goes exactly vertical from that lighthouse, and at a bearing of 70 degrees 6 kilometers away is the ship. So I need to get out my protractor, line this up, and then 70 degrees clockwise ends up looking about there. Get out my measuring stick. It's 6 kilometers away, so it's going to be 6 centimeters by the scaling that the question has given me. And there it is. Pop a dot on that. Let's call it S for ship, shall we? That's the first little piece of information. And just as you might imagine, Clap Island at a bearing of 150 degrees from the ship. Okay, so I need to measure another bearing from the ship this time. And it works in the same way. It's a north line drawn above that, and this time it's 150 degrees clockwise from that north line. Okay, so 150 down here, and then the length of that line 4 kilometers, the question says, so it's going to be 4 centimeters long, because the scaling we're told in the question is 1 centimeter on the drawing that I'm doing represents 1 kilometer in real life. So there's a dot. Let's say CL for Clap Island. Okay, and if you want, you can mark on the angles that we've drawn. We know that that's 70 degrees. We know that this is 150 degrees. This is all the information that we've got in the question translated to a physical representation. So the question says, estimate how far away the island is from the lighthouse. There's the lighthouse, there's the island, and let's measure it. Oh, I don't know. Measure that across 7.567. I'd say that's about 7.8 centimeters, which of course 1 centimeter per kilometer. 7.8 kilometers within the model, within the situation that we've had described to us. That is physically drawing bearings to represent descriptions like in question 4. I apologize for that typing error. It has led to some misunderstandings, and I hope that this goes some way to resolving those misunderstandings. Questions 5 and 6 are exactly the same idea. The idea is you figure out what bearings you're measuring from where to where. You understand the scaling on the measuring implement that you're using, how it translates to the question, and you use those constructions to find and estimate those distances. Now, obviously, because it says estimate, 7.8 is approximate. I might accept answers between 7.6 and 8 centimeters around, the answer as it is given in the question. Anyway, I hope that you are well. I hope that that helps those of you who have been struggling on this particular element of this bearings work. And for goodness sake, get your work on Teams. I will talk to you very soon.